I just realized that too.
Yeah. So I think you have to do these because these two equal. This is only fine for variables.
Alrighty, friends, let's stand for a word of prayer. Stand for a word of prayer. Ready, guys? Stretch. Stretch, 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 stretch. Oh, yeah. Open up those chest muscles. Pull your shoulders apart. Ready? And inhale. Deep breath, hold. Exhale slowly. Close your eyes. Ready? Inhale. Hold. Exhale slowly. Open your eyes. All together, let's pray. Teach me your way, Lord, that I might rely on your faithfulness. Give me an undivided heart, that I might fear your name. Amen. Have a seat, friends. Alrighty, get out your take-home practice quiz. Take-home practice quiz. It's frozen. How did it freeze? I didn't freeze it. Okay, no wonder you guys weren't praying. Take-home practice quiz. That is due on Thursday, friends. Due on Thursday. Due on Thursday. That is your homework. There is a help video for the Alex portion. I think it's only on YouTube, so I will link it to my Moodle site probably during lunch today. And that's due next class. So next class you'll have a 2-cycle Alex, as well as a couple written questions looking surprisingly similar to the written questions there. I will publish the answers to those probably tomorrow night as well.
So all this is due.
Yes. Yes. Alrighty, guys, get out your reference booklets and rotate forward. Get out your reference booklets and rotate forward. Reference, yeah, we are singing. We're going to do a quick recap of our last 2 lessons, starting with our song. You're singing with me, kids. Nice and loud. Ready? The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be each angle of a regular polygon. Ain't this fun? The sum of interior angles, sides minus 2 times 180. Hold up 5 fingers. Say OCD. OCD. Debrief with the neighbors. What are the 5 qualities of a parallelogram? Go.
Opposite sides, parallel, opposite sides, diagonals bisect each other.
All right, and then here's last lesson. We did rectangles, rhombus, and squares. Oh my. And these are the kinds of questions that I will be asking. So here I give you a square and a parallelogram, and I'm going to ask, tell me a couple ways they are the same and a couple ways they are different. Everyone in your team must take ownership of one of those qualities. Keep track. You need to be able to say 2 things that are the same and 2 things that are different. Go. Now, talk to each other. Go.
Okay.
Someone's missing. Yes, and stay with your team.
Right angles, every corner.
I'm saying they both have
When you draw diagonals.
Reference booklet's going to be where we left off on. Eventually, we're coming to here. Okay, so go. Talk to each other. 2 ways are the same, 2 ways are different.
And they're all weird because the sides are not the same.
2 ways they're the same, 2 ways they are different. You need to be able to say that, friends. 2 ways they are the same, 2 ways they are different. Okay, ready. Now we are going to a trapezoid and kite. So find your family tree. Find your quad family tree. Make sure everyone in your group knows where that's at. Quad Family tree, quad family tree. There is a family tree of quadrilaterals, absolutely. Got it. We found it? Fabulous. Now we're doing trapezoids and kites. Here is one question I want you to debrief with each other real quick. What is the singular primary difference between a parallelogram and a trapezoid? What is the singular primary difference between a parallelogram and a trapezoid? You have 10 seconds to talk it out before I land on someone. Go. 10 seconds to talk it out. What is the one singular primary difference between a trapezoid and a kite? Go, talk. No, excuse me. Trapezoid and a parallelogram. Trapezoid and a parallelogram. Go, talk it out.
Trapezoid only have one. Oh, that is true. Good job, Adrian. Wait, that's like the biggest thing.
Yeah, but that's yes, that is. Okay. We are right here, friends. We are right here. Trapezoid and a kite. By the way, just FYI, I'm going to be sending you an email about an extra credit project called the Roman Archway Project. It is a group project where there'll be a Google Doc where you can come in during your either Open 1A or 1B, and you can corral some friends. They don't have to be from this class. They could be from my other classes. And it takes about 20 to 30 minutes, and it's going to be worth a homework score. But it has to be done with other people. Yes?
Do they have to be in geometry?
Oh, that's a good question.
I want them to be in my class. No, you may not solicit help from my former students because they've obviously done it before. Darn. Although that was very appropriate thinking. Yes, sir.
Question.
Yes.
What if they weren't in your class?
Yeah.
No, we don't want no former honors geometry. How about this? You are welcome to recruit in Algebra 1, pal. If you want. On that note, but nice try, Yari. Okie dokie, here we go. Sanvi, tell me one thing that is different between a parallelogram and a kite, ma'am. I said kite twice. Trapezoid, dear. That's exactly right. Let's drag him out. Drag him out. They only have one set. This was one of the Alex problems that annoyed you guys. It only has one set of parallel lines. And the parallel sides are called the bases. And the non-parallel sides are called what, friends? What? Out loud?
Legs.
Mm-hmm. So base, legs. The angles connected to on either side of the legs are consecutive interior angles. Therefore, they are supplementary. Eyeball the midpoint on either leg. Connect. A median, that's called a median, is just an average of the what? Out loud? The median is the average of the? Out loud. The median is the average of the? That's right. So we write median equals base plus base over 2. If you want to distinguish that, first base, second base, but then I get students get hung up. Which one's the first one? Which one's the second one? And my answer is, doesn't matter. So that's why sometimes I drop those subnotations. There are 3 ways an isosceles trapezoid is congruent. By definition, you now have congruent legs. The base angles are also now going to be congruent, just like an isosceles triangle. I want you to draw in the diagonals. Just draw them in. I want you to take your fingers and finger pinch what would be the red diagonal on your diagram. Just finger pinch it. thumb and forefinger, finger pinch it, hold it, swing it around, compare it to the black, go back to the red, go back to the black, tell a neighbor, what do you notice? They're equal in length, but not bisected. What happens here is that creates two equal pieces here, two equal pieces there, which comes to play when they give you those what looks like parallelograms, and then they mark it like this. You're like, that ain't a parallelogram. That's an isosceles trapezoid. So the diagonals are congruent in length, okay, but not bisected. Congruent in length, but not bisected. There, my friends, is a trapezoid. Come over here to kite, my personal favorite. What makes a kite a kite? Consecutive, congruent sides. Congruent, consecutive sides. Anyone ever actually make a kite like this? You actually made one? I think we need to have a kite pulling contest or something because there's so much geometry involved there. Okay, go like this. The crossbars have what kind of angle in the middle? 90. Okay, watch out for kites. It's usually a mess of undercover right triangles. Heads up, green cardstock, hint, hint. All right, so the diagonals are perpendicular, of course. The blue is called the vertex angles. On the long crossbar, those are called vertex. That's bisected. Notice my hatch marks don't match top to bottom. They're bisected but not congruent. Now squiggle on the short, these are called the crossbar angles. Those are congruent but not bisected. Ready? I'd like you to put your fingers on the vertex angles and repeat after me. Fingers here on what would be the blue. Repeat after me. Say, bisected, not congruent.
Bisected, not congruent.
Switch it around, 2 fingers here. Say congruent, but not bisected. Fabulous. Go to the front page of today's lesson. All right, we are up here. All right, a couple things. So keep in mind, base does not mean bottom. So if you rotate this way, those are the bases. Base means parallel. Base means parallel. SATs, they love to rotate these sideways just to mess with you. So my median here on the left would be like this. So keep in mind, median equals base plus base over 2. I'm going to give you 1 minute and only a minute. You most likely will not finish. I want to see how far you get in a minute, all by your lonesome. Go. Doesn't matter if you finish or not, just do what you can in a single minute. Lights coming on. Alrighty guys, look up here. Doesn't matter if you didn't finish or not. Let's just see how far you got. Because of the parallel lines, go like this, parallel lines. That means these 2 yellow angles have to add up to how much? I have to add up to 180. Then these hatch marks tell me that my base angles are equal, which means I can pull this 15x minus 5 over here. And I can do 9 plus 7x plus 15x minus 5 equals 180. Maya, what'd you get for x? Okay, I guess we're going to do it together. Who has x? What'd you get? Yes, that sounds about right. That sounds about right. Yes, because we do that. X is going to equal 8 there. If you collect like terms, that's going to be positive 4 minus, so it's going to be 22. 22x equals 176, and x will equal 8. Then you simply plug it in. Up here, 7 times 8 is 56, plus 9. It's going to be 65, and this is 115. Because it's isosceles, you can do this and that. If you overlooked something, tell a neighbor, what is it you overlooked? Go. If you overlooked something, tell a neighbor, what is it you overlooked there? Okay, right-hand side. Guys, when you see these boxes, that's because equations have two sides with an equal sign, and I want to see this equation, both sides, every single box. So you start by doing the equation, and you circle, plug, chug. Physically take the time to circle. That helps your brain pick up the correct information. And for goodness sake, do not drop that 2. In fact, I recommend you circle the 2. Ready? Cross multiply, solve, and plug it in. Do your own work. And do a check. That's going to be 30 equals 5x plus 10. 30 equals 5x plus 10. Doing it here. Did you plug it in? So for x. Alrighty, guys. What's really nice about these problems, if this was a test question, you can do a check and you can know you're right even without Miss Way's key. That's what's super nice. Okay. Swing around, face your quad mates. Face each other. There's a time limit to this. I'm going to set a timer for 5 minutes. Your ambition as a team is to find all possible segment lengths and angles. Listen, kiddos, 3 times last class, when I asked someone to explain a problem, they actually couldn't. So look at eyeballs this way. A little thing about peer tutoring. Never, ever ask someone the generic question, do you understand? Never, like never. Because that is as reflex as walking in the hallway and someone asks you, how you doing? You're like, fine. It's a reflex. Or think of it this way. When you're in a store and someone asks you, like one of the workers, a generic question, do you need help? What's your standard answer? No. It's just a reflex. No, thank you. You don't want to be bothered, okay? So if you are peer tutoring, you never ask, do you understand? Instead, those of you who are helping somebody else, you put your finger physically on the paper at an angle or a side, and you ask, can you explain to me where this came from? And if they can't, then you start coaching them through it. Fingers on the paper. Be specific, not generic. You've got 5 minutes, go.
I know that. I have done these two.